नीचे नीचे आगे आशु नीचे Okay, so we'll start now. Welcome, Murshida ma'am. It is my great honor to have you with us today. So, Ms. Murshida Khatun is currently working as an assistant professor at the Department of Applied Psychology, Geetham, deemed to be University, Visakhapatnam. She graduated from University of Calcutta in 2012. She completed her master's in psychology from University of Calcutta in 2014. She was awarded the Junior Research Fellowship by the Indian Statistical Institute in 2015 for pursuing doctoral research at the Psychology Research Unit of Indian Statistical Institute, Kolkata. She carried out her doctoral research from 2015 to 2021, which focused on exploring the development of meta-memory among school-going adolescents. She received the Best Paper Award for her research work at the 8th International Conference on School Psychology, conducted by the Indian School Psychology Association at Andhra University in 2018. She also received an international travel grant from the Indian Council for Social Science Research for attending the prestigious American Psychological Association convention in 2019. Her research interests includes metacognition, cognitive psychology, psychological scale development, and quantitative data analysis. She has presented her research at various national conferences and has publications in various peer-reviewed journals. She has also delivered several invited lectures in ISI and other organizations. So we welcome you, ma'am.
Thank you so much, Ruchira, for that introduction. So good afternoon to all the participants. So the topic that I'll be discussing today is basically how we can analyze data on rating scale using RStudio. So before moving on to analysis or how to do the analysis, I'll just briefly mention a few points as to introduce R and RStudio. So I'll just open up my PPT and share it with you. I hope my screen is visible.
Yes, ma'am.
It is visible. Thank you. Okay, so just to give a brief outline of what I'll be basically discussing is what is R and RStudio, how we can download and install the two systems, a brief introduction to the layout of both these softwares, and then we move on to how we can manage our files or basically data files in RStudio, followed by descriptive statistics, some simple graphs that we can make, and lastly we'll touch upon how we can conduct reliability analysis. All right. So first, to understand what R basically is, it is basically a free software where we can do a multitude of different kinds of statistical analysis along with graphical representation. So it is one of the most popular. It has, over the years, it has gained a lot of popularity over other statistical analysis tools such as SPSS and other tools, which are obviously not free. We have to buy them, but R is completely free of cost and it is open access. So anyone can download it from the internet and install it in their systems. So it is basically a programming language and a free software environment for statistical computing and graphics that is supported by the R Foundation for Statistical Computing. Next, we come to what is RStudio. Now, RStudio basically uses the language of R for computing all different kinds of analysis. RStudio is, if we can call it, it is a more advanced format of using R. Both these systems use the same language as their base language, but RStudio is a little bit more advanced system or advanced software that is used for doing any kind of statistical computation, even data manipulation, as well as graphics. Now here we have the links to download both these systems. Now here we have to remember that in order to use RStudio, so most of my demonstrations will be on RStudio. For anyone to be able to work with RStudio, they have to have R installed, pre-installed in their system. So before downloading and installing RStudio, we must make sure that our systems have installed and downloaded and installed R first. All right. So I have also given the links here. I'll obviously be sharing my PPTs with sir, so you all can have access to that. So just to briefly show you what the layout of R looks like. The layout of R is more or less simple. It just has a console window where we can type in the different commands for executing our analysis. So this is more or less a simple outlay that we have here, and we have certain options here where we can go into and use those options for doing different kinds of analysis and other functions. So now we move on to the layout of RStudio. Okay, here we'll go into a little bit of details. So here, as you can see, there are basically 4 window panes that show up when we open RStudio. This is the first pane that we can see. This pane is basically where we write the codes for any kind of statistical analysis. The next window is basically the console window, which we just now saw in the previous slide. So this is the same window that shows up in R. Okay, this is the second window. The third one here, we can see we have some options like environment, history, connections. So this has a number of tabs here, which we can use to basically see what all is loaded into a particular R session. For example, if we are working with a particular data set, all informations relating to the number of observations or even number of missing observations, all those information will show up in this window pane. All right. For if you click on the history tab, here obviously all the commands that we have executed, those will show up based on what we have feed it into the analysis. Right. Next, we have a fourth window. Here, all the there are five options here, where we have files, plots, packages, help, and then we have another tab called viewer. So here we can access the different files that are there in our system and also set some files as the working directory. What working directory is, I'll come to it shortly. Then we have another tab called plots. So if we are executing any commands that can draw plots, so those plots will show up in this window here, on the window that is towards the right bottom side. Then we have a tab called packages. Under this tab, we can access all the list of packages that are there that can be accessed through R. Now, what are these packages? Packages are basically collection of different commands which can be used for any particular analysis. For example, if someone is willing to do a regression analysis, or any other, for example, any reliability analysis. So we have different packages for executing all these different commands or different functions, right? Then obviously we have a help tab and a viewer tab. Viewer is again where we can view certain graphical analysis, right? So from here, I would just like to exit and go to our session itself so you can have a better idea. So this is the session that I have opened up on my system. I have this, as I showed you just now, this is the pane, first window pane, the top left window pane where we can write in all our commands. So I already have some commands written here, which obviously I'll execute and show you how they can be carried out. Right? This is the console command. So whatever I execute here, whatever commands I type and run them, the results will show up in this console window. All right. So here you can see I had done some analysis. So in the environment tab, we can see that we have some data sets, and under those data sets, how many observations are there, how many variables are there in each data set. All those informations are showing up in this environment tab. History tab obviously is showing what all commands I have already executed. They're all stored in history as and when we proceed with conducting the analysis. Okay. Here we can see this region is the fourth pane where we see files. So here we can see some files that are there in my system in local disk D. Then we have plots. Obviously nothing is showing because we still haven't executed any command that will draw up any plots. Packages. So here we have multitude packages that can be used for different kinds of analysis. I'll show you a few of these packages while demonstrating. Then we have help here. So we have a lot of information that is already provided by RStudio. So just to begin with, if someone is a beginner, they can start off with this help page. They can go to an introduction to R, how we can import and export data, that we can do. All right. So, so let's just start with a particular how we can basically set a working directory. I previously mentioned a working directory. So what this working directory basically is, it is basically specifying or telling RStudio that we want this space to be dedicated to our analysis. We want a particular, let's say, it's more similar to where uh, we can tell RStudio that we want this particular file where all my executions will get loaded and saved. So we basically are telling RStudio through this working directory that we want all our executions to show up in this particular file. Okay, how do we set a particular working directory? There are multiple ways in which we can set a working directory. The first way is by typing out the command basically. So for example, let's say I want to, for example, I want to set my local disk D as my working directory. So whatever commands I write, whatever uh, uh, results I get, everything will get stored in this local disk D. But I have to specify this path to RStudio for RStudio to understand that everything has to be stored in this place. How do we do that? We basically click on this arrow and we copy this path. Right? We copy it and we paste it here. We write the command set wd and we paste the path here. But we see here we have a backslash here. So any command in RStudio, we basically replace the backslash with /. That is one thing that we have to keep in mind while setting a working directory. and we hit run for executing any command, right? Okay, it's showing some error is there. I think I missed the open and close brackets. Okay, so this has basically set my, here we can see the command has been run and it is showing here. So that means that local disk D or that particular disk has been dedicated to saving all my work in that particular directory. Another way of doing it is without writing any command. So for that, we go to this fourth pane over here and we click on these three dots. This opens up the window from where we can choose the folder where we want to save our work. For example, from here also, if I choose my local disk D and hit on open, so here all those files that were there in my local disk D are showing up in this pane. All right, so we'll just go back and see what files were there in my local disk D. So here you see these same files that were showing up here, they are showing up in this particular pane of RStudio. All right. So this basically tells RStudio that we are setting up this as our working directory. Now let's say we want to create a new folder within this working directory. So how do we do that? We already have some folders existing in that directory, but we want to create a new folder in this particular directory. So here we have that option for creating a new folder. So we click on this, we type in, give a name to that folder and click OK. So here it's showing it's creating a folder. Just taking some time. Sorry, it is taking some time here. But this is how we can create a folder. Maybe my system is a bit slow, but this is the way we can create a new folder within a working directory itself. Okay. Let's try it once again and see. I'll just try reopening this session again so that it works. Okay. So we'll try creating it again. Let's see if it works. Now that's created. So I just clicked on new folder and typed in a name for my folder. So again, maybe new one. Okay, hit OK. And these folders will show up here as well as in the, here also it's showing I've created 2 folders. Okay, so this is how we can create new folders from RStudio itself. Okay. So now since we have created our working directory, now we would like to import a particular file on which we would work on. So this file would basically have rating scale data. It is an arbitrary data set. It is not from any study or anything, but it is an arbitrary data set that we'll be working on. So how do we basically import a data set from our system into RStudio? So for that, we run a command known as read.csv. So here we can see that we have given a name to the data set that we'll be importing. I have given this name as dataset2 and equal to sign. Then we write the command for importing the data set, which is read.csv, open brackets, file.choose, again an open and close bracket, comma, header equals to t. Now this header equals to t basically means that we are telling RStudio that it has to treat the variable names as names and not as any data input. All right. So I'll just show how this is executed. So I'll just run this command here to import the data set into RStudio. So we select that and we run it. Okay, so once we run it, we can see here, it will open up a pane from where we can select the data set. So I have a number of data sets here, right? So I'll open up this file named dataset2 and open it. Okay, so this basically imports the data from my system into RStudio. Now, whether it has actually imported it or not, how do we be sure about that? To be sure whether it has been imported, we have a command for that, which is called view, capital starting with a capital V. Now here we have to remember that all these commands that we are using are case sensitive. So we have to be very mindful where we are using capital letters, small letters. So any slight mistake there, it will show, RStudio will show some kind of error. So if we run now this, so now we want to view whether the dataset has been imported into RStudio or not. So we type in view, within brackets, we give the name of the file that we have given here. All right. We have to be also careful while we are typing the name of the file. So we run this, and in the command section, or in the script section, basically where we are writing the commands, there the data set shows up in a different window here. Okay, a different tab here. This is where we are writing our codes, and when we try to view the data that we have imported, that opens up in a different tab, so we can see that this is the data set that we'll be working with. So it has a column for subject IDs, age, gender, and we have around 23 items, which are all rating scale based, and we have a total score for this entire scale. All right, so there are 23 items here. Okay. So now that we have imported the data into RStudio, we'll look at how we can analyze or do some simple analysis on this data set. So the first thing that we start off with any data set is to look at the descriptive statistics, right? So for doing that, also we have different commands. The first command that we can use is a summary, right? So this is the command that we can use for looking into the descriptive statistics of our data set. So let's try and run this command. So here we have to change, see here we have written dataset 1, but we are actually working with dataset 2. So I'll just have to change this name to dataset 2 and run this command. So you see, once I run this command, the results show up in this console window. So for each of the questions as well as all other variables, we have different estimates given here. So for example, if we look at these estimates here, so for each question we have a minimum value, first quartile, median, mean, third quartile, maximum. So here we see for different questions or different items in the data set, we have a set of different descriptive statistics. Now, this is one way of computing descriptive statistics, but there are other ways also in which we can execute commands for descriptive statistics, right? For example, okay, before going on to that, let's say for what we executed just now, we got descriptors for all the different items. But let's say we don't want for all the different items because these don't really make much sense. Item wise, any rating data does not really make sense when we compute their minimum, maximum. We don't need that. We already know the minimum, maximum of a rating scale, right? At the most, we might require the mean and median. But let's say we want to look at the summary for the total scores. So for that, we have to specify the variable that corresponds to the column designating total. So this is the command here. The command is the same, but the only difference is after specifying the data set, we are basically telling RStudio that which column they have to look into, right? So here, if you just go back to this data set, we'll see that we have a column named as total. So we want the descriptors for only this column. And we are basically ignoring all the other columns, and we just want the descriptors for this particular column. So this column has a name called total. That is what we are specifying here. So we give the name of the data set followed by a $sign, and we write the column name. And then we try to run this command. So here we see. So this is the output that we get, right? So it is giving us the minimum value, first quartile, median, mean, third quartile, maximum for just the total scores that we have obtained by summating the scores on each individual item, right? So we can play around with the windows using these signs here. So we can minimize, maximize, increase their size, shape. Okay. So this was about computing the descriptives for one particular variable. Now let's say we want to use some kind of package. We want more information than just mean, median, maximum. We don't see standard deviation here, or we don't see any other kinds of descriptive statistics like kurtosis, skewness. All those are not showing up here. So for that, we have different packages, and RStudio allows us to install those packages to execute or to get those estimates. How do we install packages? We can obviously here also we have different methods. We can either type out the command, or we can just go to this tab known as called as tool, and here also we have install packages. Okay, either we type out this command here, install.packages, and within brackets we mention the name of the package that we want to install within inverted commas. This is the entire command that we have to type out, or else if we do not want to go into so much typing, we can just go to this tools tab and hit install packages, and we can type out the name of the package here and install it. Okay, so we'll try installing one of these packages. So we are installing this package known as Psych. So this package can also be used to conduct some descriptive status analysis. So we'll try installing this. So it is being executed, as you can see here. Installing packages requires some time. It takes some time to install those packages based on their size. If they have a whole range of different, commands and analysis, they'll take some more time. So this was a pretty small one, so did not take much time. So it's already installed. Now, just installing won't do. In order to uh, tell RStudio that we need this package to run in our current session, we again have to type in another command here, which is library within brackets psych. Okay, this command basically enables RStudio to use the functions or commands that are within this package. Okay, so we'll run this command as well. So now we can use all the different functionalities that are within this package known as psych. Okay, so since we were conducting descriptives, so we'll use this package for computing descriptive statistics again here also. So this is the command that we used when we are doing a descriptive analysis using this package known as psych. We type in describe and we type in the name of the dataset that we are working with. So we're using dataset 2. So I'll just type in that and we hit run. So it has been executed. We'll look at what all information does this analysis gives us. Okay. So here you see we have some other additional estimates that we get here. Mean SD. So SD was missing in the first analysis that we did here. We do not see any SD here when we just use the summary command. So we have SD here, we have trimmed mean, minimum, maximum, range, skewness, kurtosis also we get, and standard error. So we get a whole range of different kinds of descriptive statistics when we use the psych package and the describe command for executing descriptive statistics. Right. Now there are multiple other packages, so I'm not going into all those different packages. There's another package known as HMISC. This package can also be used to get some estimates of descriptive statistics, but more or less they'll be same. There might be some differences in the commands or the estimates that we get from each of these packages. Okay, more or less the values will obviously be same whichever package we use, right? Okay, now we come to some plotting. Right, now we come to some simple plots that we can make using RStudio. So I'll discuss 3 such simple plots: scatter plot, box plot, and histogram. So let's start with scatter plot. Now here, let's try and plot. We have age here, and we also have total score for each of these cases. So let's try and plot a scatter plot for these two variables. Okay. So the command here is basically plot, and within brackets we tell RStudio which goes into which axis. So this X here basically means X axis. So we want age to go into X axis and we want the total scores to go onto Y axis. So we specify what X axis would basically measure and what Y axis would basically measure. So we specify the name of the data set followed by a $sign and the variable, which is age that we are considering here. For Y axis, we have data set name followed by $sign and our totals and the total score. Then we have this X lab over here. This is nothing but the label that we are specifying for the X axis. So we are basically specifying age as the label for the X axis. Similarly for Y axis, we are using total score as the label for the Y axis. And this main here This main is nothing but the heading that we are giving to the entire graph that we are supposed to create, we are about to create. So we are giving it the name as total score by age, right? So let's try and run this command and see what comes up. So here you see the graph is showing in this pane over here, this lower right pane over here. So we can see the age plotted on the y-axis. Total scores are plotted on the age is plotted on the x-axis. Total score is plotted on the y-axis, and we have all the different points corresponding to these two variables. And as you see that since I had mentioned all these labels here, these labels are showing up here as well. Now, if you just remove these labels and try to plot it, let's see what happens then. So if we remove these commands and try to run it, so it goes off. So we don't see any heading here, and the default is basically the what we are specifying in our command here. So for x-axis, it's showing this name, the default name that we have put, and y-axis is showing this name. But obviously, when we are using graphs for our reports or maybe publishing, we do not want these to show up because it does not make much sense, or the readers might not understand what these basically mean. So for that, we are using the label function. So we need to mention what these labels basically mean. So that is what is being carried out by these labels. All right. So this is about scatter plot. Now let's try doing a box plot here. Now for box plot, we have to basically mention the variable that we want to compute the box plot for. Also, if we want to compute box plot for two different categories, let's say for two different genders, okay, that also can be done here. So let's first just try to plot a simple box plot without any other categorization. So just type in box plot and data set to $sign total. So here you see we can sometimes we don't even need to type in the commands. Okay, the moment we put $sign, all the variables that are there in our file, they all show up, and we can just select it from here. So we just go down and select total. So we want a box plot for the total score that is there in our data set. Okay, so we select that and we try to run it. Okay, so we get a clean box plot for the total scores that are there. So here also we can mention the XLab. This is basically the total score on the y-axis. So YLab. X-axis we do not really need any title. We put them under open and close brackets. We try to run it. So here you see that what we just typed in, it's showing up here. So this, all these points, the mean, the third quartile, the first quartile, and the maximum and the minimum, they're all showing up in this x-axis named as total score. All right. So this is about box plot. Now let's say we want to see the box plot for two categories. Let's say for gender. Okay, so we also have a column for gender here. So one basically denotes male and two denotes female. So we have some twos here. These are basically females, and one signifies males. So if we want this box plot for these two different genders, how do we do that? So for that, first we have to tell RStudio that the column gender, whatever data is there, it should not be treated as numerical data. It has to be treated as a factor. So for that, we have this command. Okay, so we mention gender equal to as factor gender, right? So this basically will tell RStudio that these values under the variable gender, these values are not to be treated as numbers. They are to be treated as factors, right? So before going on to plotting box plots for different categories, we have to first mention the factors as the basically the categorical factors as this command as dot factor gender. Okay, we run this command here. Uh, okay, it's showing some kind of error here. Okay, we missed out the name of the data file. Data set to $sign. Now let's try to run this command. So step by some. There seems to be some error here. So now it has taken. So it has here we see this command has already been run and it has considered gender to be a categorical data. So now let's try to plot the total score based on gender. So for that, we have to basically use this command here. So type in box plot. We mention the variable name for which we need the box plot before the categorical data. So we are putting in the name total followed by a tilde sign, and then we put in the name of the categorical data, and we then mention the data set from which this information has to be taken and executed. We try to run this. So we have two separate box plots for the two separate genders. This here we can see is for the males. One signifies male and 2 signifies females. So we can see that for females, the scores are way lesser than the males on this particular data set. Right? So this is how we can create box plots for either any one variable, and we can also have multiple box plots based on categorical data. Right. Next, we come to histograms. So for histograms, this is also quite simple to execute. We just have to type in the command hist. This is the command for drawing any histogram, followed by the name of the data set and the variable name for which we need the histogram. So we have typed in dataset 2, followed by $sign and the name of the variable for which we need the histogram. So let's try to run this command and see. So we see the histogram is showing here. So we see there are no scores from 70 to 80 or 80 to 90. We have scores all either on the either ends of the distribution. So it is not obviously not a normally distributed data here. Okay. And also if you notice that since we did not type in any heading for our or any title for our graph, so it's showing histogram of dataset $2 total. So we do not want such titles for our graphs. So for that, we obviously use other functions here. So we can see here we have included main title like distribution of total scores, and for X lab, that is basically the the label for the x-axis, we are writing total scores, right? So if we run this command here, we'll see that this name and the x-axis title, they change. Done. And we see that the distribution of total scores, this is the title that we had put in here as the main, and total scores here. So these need to be mentioned so that our graphs are comprehensible. Okay. So this was about histogram. So I think it's almost time. So we'll quickly touch upon some simple psychometric properties of rating scale. So the first thing we try to look into is basically the reliability analysis, or maybe mostly we execute Cronbach's alpha. We try to basically we try to uh, compute the Cronbach's alpha for any rating scale, right? So for that, we have a particular package known as LTM. This is the package that we can use. There are other packages as well, but LTM is used more frequently for computing Cronbach's alpha. So in order to compute Cronbach's alpha, we have to first install this package. So we'll try to install this package first and then load it using the library command. So we'll run this. So this is where, as we say, that unzipping of the packages are happening. So it is basically extracting all the commands that are there within the within the LTM package. So this is complete. So whenever we see this arrow here, small arrow here, this means that the execution is complete, and we can move on to the next command. So we move on to loading the installation is done. Now we have to load the package within this session, right? So we try to run this command library LTM, and then we can use it for computing the Cronbach's alpha. Okay, so it has loaded. Now we try to run the. Okay, so before moving on to computing Cronbach's alpha, we first have to specify the range of the data that we need for computing Cronbach's alpha. So if we do not mention the range of the columns, it will take in all these different columns that are here. It will take in gender, age as well into its calculation. So we do not want that. We just want columns from Q1 till Q23 here. We just have to separate out this data for computing the Cronbach's alpha. Otherwise, it will take all the different values that are there. It will take total also. It will also consider gender, age into its calculation. We do not want that. So for that, we'll have to separate out the data. How do we do that? We use this command. So we give a name. It is as if we are creating a different data frame or a different data set, which is basically a subset of the master data set. So we give it a name. Here I have given it the name as scale, followed by an equal to sign. And then we put in the command, which is data.frame. This is what will create or separate out the data set that we want for computing our Cronbach's alpha. So we put in data.frame. Then within brackets, we specify the file name, and within square brackets, we see after square brackets, we have a comma here. What is this comma denoting? This comma denotes that we are not separating out any columns. We just want a range of, we are not separating out any rows here, but we want to separate out a range of columns here. So any range before this comma sign denotes range of rows, and any range of range here after the comma sign, it is basically denotes columns. Okay, so I have put in column 4 to column 26 after the comma sign. All right, with that goes within a square brackets. All right, and we close the curly brackets here. Sorry, simple brackets here. And try to run this entire command. Okay. So this has basically here the command has already run and it has separated out the data. Now whether it has separated out the data or not, how do we be sure of that? So similar to viewing a data, we can just type in the view command here. This I already showed while we were importing the data set, master data set. So we use that same command to see whether we have successfully separated out the data for our reliability analysis or not. So we run this command here, view scale. So now we see that a new tab is showing up without the other columns here. So we do not have any gender, we do not have age, we do not have the column subject, and also we do not have the column total. Okay, it is only separated out the different items that are there in the scale. So we want only this data for computing the Cronbach's alpha. Okay, so for that we type in for now we come to the main part that we want to compute the Cronbach's alpha. So for that we type in cronbach.alpha within brackets the name of the subset or subset of the data basically, which we have named as scale. Okay, we try to run this. So this gives us the Cronbach's alpha as we can see here. The result has shown up here in this lower pane, 0.995. So the Cronbach's alpha is quite high for this particular scale. So it shows how many items we have. So it has 23 items. Sample units basically means the number of cases that we have in our sample or the data set. And this is the estimate of the Cronbach's alpha. Okay. Now, when we are computing Cronbach's alpha, we also need some other estimates like the inter-item correlations and also the item total correlations. So all those are not showing up here. So for us to be able to see or get those values, we have to go for some other package. So under this package, this is the only thing that we can get, right? So that is why there are different packages that are dedicated to different set of information that they can provide. So again, we already have psych loaded here, so we don't need to we already had installed and called up psych data psych package, so we don't need to again install and do that, but we can use that same package for calculating the Cronbach's alpha along with some other informations. But here the command changes a little bit. Here the command is just alpha and not cronbach.alpha as we had used previously. So the command changes here a little bit. It is alpha within brackets scale. We try to run this and see what output we get. So here we get a more detailed output as compared to the other command, that is cronbach.alpha. Here we get the raw alpha, which is 0.99, which is same as the previous one here, right? So this raw alpha is basically this alpha that we computed. Then we have some other estimates as well, but we don't want to go into all that just as yet. So here we see some other statistics showing here, such as raw R. This raw R is basically the correlation that the inter-item correlations that we can see among the items, right? Then we have this R core over here. This is basically the item total correlation. Okay. What do we understand by item total? It is basically how the score on each item is basically correlating with the total score. Okay, so the higher this inter-item correlation is, the more reliable our scale is. So here we see that most of these item total correlations are above 80. So we can say that all these items are reliable and we can use them. We do not need to drop out any of these questions or these items, right? Now this R drop is basically gives an estimate of the change in Cronbach's alpha if we drop that item, whether it increases. So sometimes what happens, where we might have some items which have low in item total correlations, like lower than 0.5. So if we have those kind of items, if we drop those items, so the Cronbach's alpha would likely increase. So this column here, R drop, this column here, this gives us an estimate of what will be the Cronbach's alpha if we drop that item from the scale. So here we do not see much change even if we drop each of these items. So this indicates that the scale is highly reliable and we do not need to drop any item from this scale. So I think that is all that I had to present. So if any questions are there, I would be happy to answer those questions. I'll stop sharing my screen. I'll obviously share my PPT and also I'll give some names of reference books which you all can follow for computing these. You can try your hand on dealing with different kinds of rating scale data. Yeah, so Anupama is asking how can we learn the rest of the commands? Obviously, R is obviously a language-driven software, so it will take some time. The best way to learn is through using data sets. Okay, so if you have some data sets, you can obviously, there are a lot of good tutorials on YouTube as well. So there also you can take help, and obviously there are some good resources like books are there. One good book is by R. Evans. This is a book for those who are just starting with R. This is a good book for them. And there's another a little bit more as advanced book that is by Rash Kobinger and Yanagida. I'll try sharing these books also. I have the PDF formats of these books, so I can share these books also, and also I'll share the PPT and. I'll also try sharing the commands that I just showed you. Okay, so you can try using those commands and working with your own data sets. All right. Yeah. If you have any other questions, I would.
Ma'am, where do we find the packages for the different functions?
Okay, I'll just show it to you again, where we can find the packages. One is through typing in this command here. We can just type in install.packages and if you're asking that how do we get idea about which package to use when, that obviously you'll learn through books. Books have this information as to which package will help us get into these kind of analysis. These informations you can get through books, or there are different blog posts also which are helpful in understanding which packages we should go for different kinds of analysis. So that is one way. And if you are asking about how we can install and download these packages, then we have simple command install.packages. Within brackets and within open and close inverted commas, we type in the name of the package. If we do not want to type in this command, there is another shorter or shortcut to get to these packages, that is through this command here called tools. So under tools, the first option that we see, it's in install packages. If we click on that, it will open up this small window here. Here we can type in the name of the package that we want to install and we hit this install button here. This will install the package in your session.
Ma'am, actually, we're not
Yes.
able to see your presentation. We're just seeing your image, ma'am.
You're not. Okay, I stopped sharing, right? Sorry, I'm so sorry. I'll share it again. Now is it visible? Now is it visible?
Yes, ma'am.
Yeah, okay. So I'll just show it once again. So for installing any package, we can either type in this particular command here, install.packages. Within brackets, we give the name of the package. So for example, we use this package known as psych, PSYCH, right? Within brackets and within inverted commas. So we have to remember these small details as well, that putting the command within brackets and within inverted commas. Okay, so if you see when we type in library and then this command here, when we are basically calling up the psych package within our particular current session, there we are not using any inverted commas. So we have to be very mindful about these slight details that we use while writing out commands. Okay, so one way of installing package is by writing out or typing out this command. The other shorter way is to go to this tools section, and under tools we'll find this option called install packages. If we click on this, we'll have a space to type out. Under packages here, we can type out the name of the package, and we can click on this install button here. This will install the package. So installation is basically telling RStudio that we want this package, we want to use this package. Okay, so it will basically install it within your R session, but even after installing, in order to use that package, we'll have to use another command, which is library, within brackets the name of the package. This will help us use the package for computing the other uh, analysis. Okay, I hope I have answered your question.
Ma'am, one last question, ma'am.
Yes, please.
Like suppose because these are programs
Hmm.
sometimes they may not run as thought,
Ah,
as we expect.
yes.
There may be some glitch here and there.
Yes,
Ma'am,
yes,
regarding that,
absolutely.
like how do we troubleshoot or where do we go to troubleshoot regarding that? Could you please advise us?
Okay, I'll share my experience how I learned to troubleshoot them is basically by interacting with different people who actually work on RStudio. Okay, one is that way, but also if you find some problem with executing them, you can obviously Google them up. Okay, you'll get a lot of blogs that there are certain communities also who work on these packages and these commands. Okay, so we can Google search these communities also. Okay, where you can basically type in your queries and they can answer back to you. All right.
Thank you, ma'am.
There is, yeah, okay. But the best way to learn RStudio is by making mistakes only. Okay, so as and when we make more mistakes, we'll understand where we are going wrong, and obviously with more practice we'll get over those mistakes. And as I already told you that it is very this RStudio is very case sensitive as well as command sensitive. So we have to remember, or basically it will come with practice, where we have to use simple brackets, square brackets. Like here we use square brackets. So where we have to use which kind of bracket, that those kind of understanding, that will only come with practice. All right.
Thank you, ma'am.
Yeah. Okay. So I think we can. Yes, Dola ma'am, I'll definitely share the PPT as well as the commands. I'll just copy the commands in a Word file. I'll share them as well. So, sir, I think no questions are there anymore. So, can we
Yeah, thank you. Thank you.
Thank you so much, sir, for having me. Yeah.
Your very busy schedule. You have added time for us. Thank you.
Thank you for
You
inviting me,
covered
sir.
the basic introduction of our studio. So
Thank
now they will get some data
Yes.
from Moshida, and
Uh,
after that they will do all sorts of analysis, so they can
Sure.
understand now.
Yes,
So,
yes.
Tell
Sure,
you.
sure. Thank you so much, sir, for having me. I really had a good time taking this session. And I look forward to more such sessions with all the participants, and all the best to all the participants.
Thank you.
Yeah, thank you so much, sir. Thank you, everyone.
Hello. Now the data that I shared with you in the WhatsApp group. So you can download the R and the R Studio. You can download the R and R Studio, and then at first, please read the data on the R Studio. Now, then one by one, we can solve some of the basic, we can run some of the basic commands so that you have a general understanding of how R works. So we are giving you 5 minutes to download the R, and please read the entire data set in the R console. Yes, I'm sharing the link of downloading the R. Just a minute. So can we begin now?
ডাউনলোড করেছি কিনা জিজ্ঞাসা করো
Have you all downloaded? Those of you can right now.
Yes, ma'am. Yes, ma'am.
Yes, ma'am. Download.
Okay. So we'll start with it now. So first, have you you have the data that I gave you in your laptop, right? The data set that I provided you, you have it in your laptop?
Yes.
Okay. So
Yes, ma'am.
now you open, okay, I'm sharing the screen. So you open this file in your Microsoft Excel. Okay, and most probably you'll see that in your one, this A1 is blank, right? There's nothing written on A1 in your ones. Is that so?
Yes.
Right. So now, since there is nothing written on this header, so we have to give it some name or something we have to write there so that R can recognize what that stands for. Okay. So for that purpose, I have written ID here. So you can give it a name that you want. And then you save that copy. Please let me know when you have done that and saved this copy. Have you saved it?
Yes.
One second. Huh. Yes, ma'am. Yeah, I got it. Thank you. So you have saved it successfully. So now you go to your R studio.
পার্টিসিপেন্টসে ক্লিক করো মিউট অন করে রাখো।
Okay, so now in your R console, you please write C. So now I have to tell R to locate where my file is. Okay, so now you have to you just create any vector. So for this purpose, I have created the vector trial because this is a trial data, and you write this command trial equal to read.csv.
Excuse me, ma'am. You need to reshare your screen because we can see only the Excel file, not the R Studio.
Oh, okay. One second. Now is it visible, no?
Yes, ma'am. Thank you.
So now you create any vector of your preference, whatever you want to name it. So for this purpose, I've named it trial, and you then it put an equal to, then write this command read.csv, open first bracket, file.choose, open first and close first bracket, and this command, this entire command. And then press an enter.
That window aspect, say window converting.
So you will see that after you have written this command, a window like this will open. Is it opening? Okay. So after this window is opened, so we have to select the file we are working with. Okay. So for this purpose, we are working with H50 trial. So after selecting this, we'll click open. Okay. So you'll see that R has read the table or the file that we want to work with. Okay. So now after this, if you write this command view trial, then you'll see here in this panel, the entire data set is visible. So you can understand that R has read properly whatever you wanted it to read. Okay. So the view command is used for this purpose. And then we can see if we want to check the structure of the data set. So we can also have this, write this command and check its structure. Vector. So we'll write this command str, and in the bracket we'll write the vector, that is the trial. So you can see this is the whole structure of our data that we are working with. Okay. So these are the items. There are 9 items. Okay. These are the 9 items, and these are the individual who have responded. So 51 to 100, they are the individuals. And they have given these ratings to each of the items. So the function of structure is that it gives you an idea of the entire data set that you are working with. Okay. And if you want to check the dimension of your data set, so you can use this function, dim within brackets, first bracket trial. And you'll see that there are 50 rows and 10 columns. Okay. So this is a basic of how you can see that what is the structure and dimension, how many rows and columns are there in your file and data set. And so now sir will show you how to do the reliability like the alpha, Cronbach's alpha, using the library package. Okay. So I'm handing it over to sir now. So you can go, you can also do it on your own following this, this presentation right now. Okay.
खूप मजा ना. So here is one window. There you can write down the R script. Okay. Is it clear to all of you?
Yes, sir.
Yes, sir, it is clear.
So in this R script, you can write down the script, and after that you can do lot of the analysis. So here you can write down the summary bracket. Your variable name is 10.
Trial.
Trial. Okay. So whatever your command, you can write down all of them. Okay. So this is the advantage when you apply the R script window. So you can select both. And then this run. Okay. Number. Okay.
Trial spelling.
So there is actually a spelling mistake. Instead of trial, it is trail. Henceforth, that structure couldn't work.
Trail spelling mistake.
Spelling ta kya hai?
TRIAL. नीचे नीचे.
আর কিছু control করে দিচ্ছি।
Oh, so it was actually trail.
Trail.
Trail, yes.
So you need to write trail, not trial. TRAIL instead of TRIAL.
So you have understood actually the limitation. Okay, good. Now you select these two only, last two. Okay, so the advantage is that when you write down the str, then you can get this information . You will get the information that is what is the structure. So that is the advantage if you directly write down this one. So I am removing all of them. Now I am writing DIM. So it is clear that is the dim means 50 and trail that is the 10. Why it is 10? Because first one is the ID. Okay. And this ID including the ID, the total will be the 10. So we have to remove the ID because ID is not our analysis. Okay. And here we can find out the minimum, maximum, but this ID is not required here. So we have to remove the ID. How we can remove? I can write down the trail name. Equal to trail what bracket, box bracket, -1. Then enter. Now trail name. Dim trail name. DIM trail name. Is it clear now? So you can truncate the data as far as your need.
With the help of this command, trail new, this is a new vector that we have formed, trail -1. So it will give you the
-1 means the first position. Okay. Next, lecture. Which is sum put there. Let us tell new sum. Sum equal to apply bracket tell new comma 1 comma sum. Enter. Then you write down the paste tell new sum. Paste tell new sum. Is it clear? So this is basically the row-wise sum for all the items. So 1 indicates row, 2 indicates column. Is it clear to all of you? So we have to assess the item total correlation. Then we can write down, let us see one bracket, tell me comma, tell me sum. Data vector bracket. Tell me code नाम देता. Equal to interval. Paste वाले बेटा दिलो interval. Is it clear to all of you? Hello.
Yes, sir.
Yes, sir.
So this is the item total correlation. Okay. Now, this correlation indicates what? How do we interpret this data? Level plot bracket. Tell new code. So this is visible. I have created the plot.
Yes, sir. Very sure.
Yes, sir.
So this plot indicates the items out of these 9 items. Only few items are below 0.5, right? Maybe only one item. Yes, maybe one item. So I-74. So that is the item. So for the item analysis, we can think about whether we will include this item in our model or not. So madam has taught you the psych package. Library psych. Psych. Enter. তারপরে দেখো আলফা ব্র্যাকেটে দেখো কি নাম ট্রেল ভিউ কো না ট্রেল ভিউ ট্রেল ভিউ only sometimes ট্রেল হেল্প এন্টার যাও উপরে যাও So, okay, now look at it. Here the standardized alpha is 0.8. Is it clear to all of you?
Yes,
That
sir. It is
means,
clearly visible.
yes, that means the reliability is very high. Okay, so under this condition, it is not necessary to remove the item 0.29. Okay, and if you want to remove the 0.29, then alpha will be affected. Maybe it will be high or maybe low. So it is better, for example, you go to this R drop. Okay, so this is the R code. It is 0.21 alpha. This item total correlation is 0.21 for item 74. And if you drop it, then the alpha value will be low. Okay. So it is not necessary. Or we can check, that is if we can remove, because it is a standardized alpha 0.8. The basic assumption that all the items must be intercorrelated to each other. So therefore we can do another analysis. We can write down pairs, P-A-I-R-S, panels, bracketed trial name, enter. Okay. Is it clear? Now you can find out. Now you can find out the inter-item correlation. Okay. And some items we will find it is the very good. The base fit line or the regression line. So they are the good items. But there are some items, they are not very much related with each other. Okay. So based upon that, you can think about whether you will keep the items or not. Trial new frame. Trial new frame. Equal to data dot frame. Okay, bracket. Trial new. Comma. Trial new sum. Then you write down pairs dot panels. Bracketed trial new frame. Enter. Okay. Whether this picture is clear to all of you? Hello. So here you can find out that is the regression line is very good. But particularly for this item, the regression line is poor. So you must be very much careful when you want to select the items. Okay. So now you practice this exercise because I have given you the data. So you practice the exercise, and then if you have any problem, please do write in the WhatsApp. Ruchira will guide you. Is it clear to all of you? Okay.
Yes, sir.
So now I am requesting Ruchira for any announcement.
So yes, I'll send you the PPT that ma'am has presented today and as well as the previous PPTs. So you can follow that and conduct the art studio. So, and if you have any problem, then feel free to ask us and we'll guide you as much as possible. Okay. So, and tomorrow we are meeting at the same time at, I just start from 11 a.m. Okay. Sorry. Sorry. Hello.
Madam, one doubt.
Yes.
How you import the data which you sent in the R file, Excel file, which you import in R? That please show again.
Okay. So for that, okay, so you have to write this command. Read.csv, open first bracket, file.choose, open first and close first bracket, comma, header equal to T, comma, first bracket, end first bracket. So this is the command that you have to use for reading it from Microsoft Excel.
Yes, ma'am. Thank you.
Okay.
I'm doing that read.csv, but it is not coming, madam.
It is not coming.
Yes, ma'am.
Maybe whatever Excel.
Please show in your data which you given the trail data, how you
CSV.
imported it data.
See the file that was saved in Microsoft Excel, it should be saved in CSV mode. Okay.
CSV mode. Okay.
Right. Not in any other mode, not in Excel mode or any other mode, but in CSV mode. Then only R can like read the data.
Okay, ma'am. Thank you. I'll try, ma'am. Thank you.
Yeah. Okay. So thank you, everyone. See you tomorrow.